Hey everyone, thank you for joining us today. My name is Chayan Biswas. I'm a senior manager of product management with Amazon Aurora. And presenting with me today is Anam Jangsher. She is the senior product manager for Aurora Serverless. In case you're wondering whether you're in the right room or not, this is DAT 302, and we'll be talking about the next version of Aurora Serverless, what we call as Aurora Serverless V2. So with that out of the way, on the agenda today is lots of stuff. Firstly, we are going to dive deeper into capabilities we have built into Aurora Serverless V2 that you can use to build and operate even the most demanding, most critical workloads. Aurora Serverless V2 is currently in preview. So we have sprinkled in quite a few demos, which give you a sneak peek into some of the capabilities that we are building into the GA product once it's going to become available. Through the course of running the preview, talking to customers, and building the product itself, we have learned quite a few things. And in the next section, we'll get into sharing some of those tips and tricks that can help you operate your applications better and more efficiently with Aurora Serverless V2. Finally, we have put in a lot of thought and effort into ensuring that you can get started with serverless databases with as little friction as possible. So we'll give you the ways through which you can get started and also show you a demo which will help you get a sense of how serverless V2 databases can be set up. We have a lot of ground to cover, so let's get started. But before I move forward, I want to get a sense of the room. So by a show of hands, how many of you are familiar with Aurora? All right, quite a few. How many of you are using Aurora? All right, tons of people here familiar with Aurora, also experienced with Aurora. How about Aurora Serverless V1, the first version of Aurora Serverless? All right, some hands here. So we are not going to spend, the reason why I'm asking that is we are not going to spend too much time getting to the details of Aurora. There's lots of innovation that has gone into this product all across the relational database stack. But for context of those who may not be familiar with Aurora, I'm just going to provide a quick brief overview. There's another session being presented by one of my colleagues, Richard Baymeyer. You can look at DAT 401 for a deep dive into Aurora databases. So what is Aurora? Aurora is a MySQL and Postgres compatible relational database built for the cloud to provide you the performance and availability of commercial databases at 1/10 the cost. And we have a nice little distinction of also being the fastest growing service in AWS's history. We have held this title for a few years, so very proud of that. What's critical and more important in terms of understanding how serverless databases function is the core underpinning architecture that helped us build serverless databases on top of Aurora. So Aurora uses a purpose-built distributed storage layer, which stores your data across 3 availability zones. We keep 6 copies of your data. And depending on the size of your database, your data is striped across hundreds or even thousands of storage nodes. So with that, what you get is better availability, durability, and performance. When we think about regular database operations, there's this separation of storage and compute now, wherein the storage layer is doing operations such as backups. And we don't have to wake up your database instance, your compute, to do these backups anymore. The other key piece to note here is that in addition to your storage layer being automatically scaling, you can also add up to 15 read replicas. These are low latency read replicas connected to the same storage volume, and you can use these to scale out your read workloads. And most importantly, because there's this separation of compute now, we can scale compute separately and independently of the storage layer. So we can scale it up and down, add more read replicas, remove read replicas, without having to worry about what happens to storage. So with that foundation, let's look at why we built Aurora Serverless in the first place. What you see here is a chart of CPU utilizations across our fleet. We picked a few examples. And this ton of variability, as you see here. Now, databases, relational databases, tend to be core components of your application stacks. And you don't want to be in a situation where your database capacity is the reason why you run out. Your application, you can scale it, you can use auto-scaling groups, you can have containers, Lambda functions. But database, you want adequate capacity so that you can continue to operate efficiently and effectively. So then there are two choices. One choice is that you can provision for what you estimate to be your peak, and you leave some room. But that tends to be expensive. Again, going back to the charts, as you see, there's the average utilization and the peak utilization. And the delta between the two is what you're wasting, because you are not using most of the capacity that you're provisioning most of the time. The alternative to that is that you can watch your database continuously for how it is being utilized. And when the time arises, you can scale it up or scale it down. Now, Aurora already makes it easy for you to do that. You can add one of those read replicas I was talking about, which is a larger or smaller read replica, failovers are faster, and then you can scale through that mechanism. But with that also, what you're incurring is a little bit of downtime, 30 seconds or so. And you lose your connections, you lose your buffer pool, your caches, everything. So that's not ideal either. So given all these restrictions that we saw customers were dealing with, the challenges, we built Aurora Serverless, and we launched the first version in 2018. Since then, thousands of customers have used Aurora Serverless. So let's look at what Aurora Serverless is in the first place. So it is an on-demand auto-scaling configuration for Aurora databases. And in this configuration, your database capacity, compute capacity, is automatically adjusted to meet the demands of your application. So as your application requirements change, the compute capacity scales up or down to adjust to what is needed. Of course, you only pay for the resources you are using at that point in time, instead of paying for peak capacity if you are provisioning for that. In the next version of Aurora Serverless, what we call as Aurora Serverless V2, what we are providing is instant and fine-grained scaling adjustments so that you can operate even the most demanding applications on Aurora Serverless databases and run them without having to worry about database capacity management. Now, serverless databases, there's a lot of interest across industries and across different workloads where customers have told us they want to go serverless. I'm going to run you through a few examples, few subsets of where we saw customers could benefit from serverless databases, and what are the requirements of these demanding workloads that we see. So the first one I'm going to talk about is software as a service, SaaS applications. So in these applications, they tend to have thousands, sometimes hundreds of thousands of end users. And these end users could have their own little databases. Now, operating these thousands of databases is cumbersome. So what SaaS vendors end up doing is that they consolidate a bunch of these databases into one Aurora cluster to be more cost-effective and to improve utilization. But there's a trade-off there. The trade-off is that you no longer have the granularity of operational controls per database. If you want to restore a database back to a certain point in time, that's no longer possible because now it's co-located with maybe a few hundred others. And it also requires you to continuously watch what's going on in the database. If there's a busy workload, if an end user grows suddenly, then you don't want them to be impacting other workloads there. So serverless databases, in this case, you can just run individual databases on serverless and let Aurora manage the capacity for those databases instead of losing out the operational controls that I was describing. Next example, let's consider an enterprise wherein you have maybe thousands of applications, each backed by its own one or more relational databases. Now, over time, these application requirements could evolve. Oftentimes, we see applications get end-of-lifed, so you have to release the capacity. On the other hand, you could have situations where an application grows in its requirements and its capacity needs, and you need to provision more capacity for it. So managing thousands of databases on a tight budget is also difficult. Again, serverless comes into play here because you don't have to do this balancing between an application that needs to scale down and an application that needs to scale up. Serverless handles that for you. I'm going to take another example. And these are situations you consider an online service, delivery platform, wherein you have reached, maybe the workload has reached the limits of what an individual instance can provide in terms of write throughput. In those situations, customers choose to distribute their database, also known as sharding, across multiple Aurora clusters. Now, the thing that customers have to think through is how many such clusters should we provision? If you provision too few, this is a situation where you continue to grow. And then you have to go in and redistribute your data, which will take time, and it will take effort and monitoring. The alternative to that is you can create as many clusters as you can imagine ever needing, as many shards you can imagine ever needing. But then there's a cost to it. Certain shards get used more, certain don't get used as much, and you then have to consolidate them back for better cost efficiency. With serverless, that worry goes out. So you can create as many shards as you ever imagine needing, and then run them on serverless, and because it's going to scale automatically based on what is needed, you don't have to worry about paying excess for the capacity. So those are some examples of what we saw as demanding workloads where we need to build more capabilities. One common theme we saw across all these workloads that we were, and all the customers we were talking to was that they need immediate access to capacity when they need to scale. And that's true whether you have one database or if you have 100 or 1,000. When you're using serverless databases, you want to be able to get access to that capacity immediately. So instant scaling is one key capability that we built into Aurora Serverless V2. And most importantly, this scaling is non-disruptive. So you have a busy workload, you have lots of transactions going in, you're using temporary tables, or maybe you have a long-running transaction, which is taking maybe several seconds or minutes. In those situations, we are able to scale without stopping those transactions or dropping any connections instantly. The next piece is that with capacity management, you want to be as close to the demand as possible. If you provide too much, you are, of course, again, wasting. So with Serverless V2, we make sure that we adjust the capacity closely matching the demands of your application. Finally, when we think about production applications, they typically need high availability. So multi-AZ capabilities, you also potentially need to be able to recover from disasters, so disaster recovery is important. Then scalability of reads within a region, across regions. You also want better visibility into what's going on in your database and better controls over connections, availability, and manageability of your database itself. So we have ensured that in Aurora Serverless V2, we are building the capabilities that are needed for demanding workloads like this, the ones I described. I'm going to, over the course of the next few slides, go into these three pillars more deeper. So let's start with instant scaling. We achieve instant scaling through what we call as in-place scaling. And what do we mean by that? By in-place scaling, what we mean is we take a running database process and give it more CPU, more memory, more networking resources. And that's how we also make it non-disruptive. If there's a workload going on, there's a bunch of transactions going on, we don't have to wait for all these transactions to pause or find a gap in that. We can just add the resources and let this workload grow. Underneath, of course, these are serverless databases, but they do run on real machines. So with our experience operating Aurora databases and RDS databases, arguably we have the largest fleet of relational databases that we manage. We use that experience to also manage the underlying capacity and add more capacity, expand the fleet as needed. There could also be situations where your underlying machine runs out of capacity. It's possible because it's a physical machine. In those situations, what we do is we identify the idling instances that are probably not seeing as much activity or there's probably no activity in them. And then we move them to other machines where there's more room. And we do this, again, non-disruptively. We preserve all the connections, the buffer pool, and all the other caches that come with the database. Finally, the scale downs are also faster compared to Serverless V1, up to 15 times faster. But we scale down carefully. Because what we don't want to be doing is evict a bunch of your buffer pool pages, and which could, in turn, result in a situation where you have to go back and fetch them again from the database. There's more I/O cost. More importantly, your performance could take an impact, a hit, because there's more latency in doing that operation, of course. So buffer pool is the primary cache in your database. So you can call it buffer pool, buffer cache, pick your terminology. We scale the buffer pool along with the database instance. So as there's more workload going in, we measure the pressure on these data structures within your relational database, and then scale up the buffer pool to match what is needed. Which means, in case of Aurora MySQL, the InnoDB buffer pool size. In case of Postgres, the shared buffers parameter. These two parameters, Aurora is managing for you. You don't have to. And the default allocation that we use between what's going in for buffer pool versus heap is 75% for buffer pool and 25% for heap, which is used for things like sorts and other operations like that. When we scale down, as I was saying, we do it carefully, and we use a combination of least frequently used and least recently used algorithms. So I have a nice little animation, which I'm going to run through to show you how it all plays out. So as pages are read from the buffer pool, they become hotter. So these are hot pages. And these are less likely to be evicted from the buffer pool when we do need to scale down. There could be situations where we are reading new pages from storage. And as we read these pages, we don't know how they are going to be used in the future. But we also don't want to treat them as cold pages, which are prone to being evicted. In such cases, what we do is we treat them as warm pages and let them stick around so that if they get used more often, you know what, they will become hotter. If they don't, then they become cold pages. And cold pages, the ones in gray here, are the ones which are our targets for evicting. So when the time comes and when we realize that there's not enough workload, the pressure on these data structures is reducing, in those situations, we take these cold pages, we evict them, we drop them, reclaim the memory back, and shrink the buffer pool to match the size of the instance at that point in time. So that was about instance scaling. Next, I'm going to talk about how we achieve fine-grained scaling and how we do it. I've been telling you about Aurora capacity and capacity in general a lot. The unit we use to measure that is called as Aurora capacity unit in Aurora Serverless databases. One Aurora capacity unit comes with 2 gigabytes of memory with associated CPU and networking. And you can imagine the CPU and networking being similar to what you get with regular Aurora instances. The ratio is similar. The starting capacity with serverless is very low. It's half an ACU, which translates to about 1 gigabyte of memory, so very small database instance size that you can start with. And then any adjustment we make from there on can be in as little as half an ACU. So let's take an example. If you're running a database on 32 ACUs, we can take you to, say, 35, 37, or as little as 32.5. We can increase you with just half an ACU capacity as well. And all that is determined based on what's going on in your database. We talked a lot about instant scaling, fine-grained scaling. There are a few factors we, of course, use to determine when and how to scale. One of the factors that you may want to remember is that the scaling rate is dependent on the current size of the instance. So if your database size is larger, it is more likely to be able to scale to a higher capacity or more quickly. The other factors, of course, are CPU, memory, and networking. So CPU, depending on how much CPU is being utilized, will scale up your database instance. Same thing with memory. Pressure on both buffer pool and heap will determine that and scale your database instance based on that. Finally, there's network. So if you're doing, let's say, a bulk operation, bulk load operation, and you need more network throughput, we detect that and give you more capacity to have higher network throughput. So that's a lot of talk. We need to walk the talk as well. So now you have a nice little demo for us here, isn't it?
Absolutely.
All right.
So now, what we're going to look at is how do you get started? So I'm going to show you how simple and easy is it to create an Aurora Serverless V2. On the screen, you see RDS console, which you are all probably familiar with. All you have to do is click Create Database, and it's the same workflow that you have with Aurora. So I have Aurora selected, and in addition, you see I have both MySQL and Postgres options available, which you'll have at GA. Now here's the new part. So now I'll select Show Filters. And here in the options, I'm only going to select the options that support Serverless V2, and I'll see the drop-down list, all the options that are selected there. For the rest of the stuff, it's the same stuff. Let's just give it a name quickly. I'm going to call it Serverless V2 Demo. Let's give it a password. And go ahead and confirm this password. So the thing you want to pay attention to is right here. So on instance configuration, I'm going to select serverless. This is where I give the capacity range, so your minimum capacity and your maximum capacity in ACUs. Let's quickly just scroll down. Let's not create a replica just yet. And for the rest of the options, I'm just going to do like default ones and click Create Database. Once I refresh, there you have it, an Aurora cluster with a writer instance, which is an Aurora Serverless V2. So Chayan, this is how simple it is to create an Aurora Serverless V2 database. So now, I want to talk about how scaling works. So for this demo, let's say I'm a developer. I'm going to walk you through a flash sale scenario. So here, I want to test if our system can tolerate our upcoming sale. So to do that, I'm using a couple of different components. First, I'm using artillery to generate load. What it does is it shoots off a bunch of different Lambda functions, which basically process the orders, which in turn calls your database. And here, we're using Aurora Serverless V2 as the transactional database, which is going to scale up based on the workload that we see. And now I'm going to show you that, so we'll use the CloudWatch dashboard to look at scaling. We're looking at two metrics here. So the blue line, which is the total number of orders that we have. And the other line other metric we're looking at is the orange line right there, which is going to be your database capacity. So on the left side, you have the total number of orders, which is just the sum of orders coming in with the blue line. And on the right side, the scale is your database capacity in ACUs. I'm also going to be looking at some additional metrics. So let me just quickly run a query right here. So I'm going to look at buffer pool size, which, as Shan mentioned before, should increase, decrease based on what's happening with scaling. And I'm looking at the InnoDB history length, which basically records the number of changes that are happening. What I'm going to do next is just run this query in a loop. It'll run after every couple of seconds, so we can observe these two background processes. Let's get the sale started now. And I'm just going to start off artillery, which is basically going to start off a bunch of different Lambda functions. So here, remember, blue line is the total number of orders. So when this line goes up, that means the sale has started, and the orders are coming in, and it's rising. Orange line, database capacity, not doing anything right now because it can handle the load. And as soon as the load increases so much that we need to scale it up, you'll see the orange line going up. Let's just speed it up a little bit here. So you see the orange line is has started responding to the increase in orders coming in. On the background processes now, what I expect to see is that the buffer size should start increasing. So it's at 15, 16 right now. The history length is also increasing, 3,800 almost I saw there. Now is the part where the sale's ending. This is basically the shortest sale in history. So the orders are coming down, the database capacity is also coming down. And you see there's like a very intentional stepwise decrease in the database capacity. So we want to take a very cautious approach when we're scaling it down. We don't want to take buffer pool away too quickly and interrupt your workload. So here you see that the buffer pool size has come down to almost 3 GB, and the InnoDB history length, it went up to 3,800, and it's also coming down, which is showing that purging is happening in the background. So in this demo, you saw that Aurora Serverless V2 will scale up corresponding to your workload in just the right amount, which is what you pay for. And you also saw that we not only optimize your foreground processes, such as your queries and stuff, but also your background processes to make sure we provide you with the best experience. So what do you think, Shan?
I just placed an order, even though it was a
Oh, perfect.
So get it shipped to me quickly.
Absolutely.
All right. So next, thank you, Anum, for that demo. That was amazing. Next, I'm going to talk about what are the different capabilities these demanding workloads we are talking about need. One is high availability, and with that, also read scalability. So as we stated previously, there are up to 15 read replicas you can add. And with Aurora Serverless V2, you can make all of them serverless. One piece to note here is that you will specify the capacity, the minimum and maximum capacity for your cluster. And so all these instances are going to inherit that capacity configuration from the cluster. Another interesting piece to note here is when it comes to high availability, Aurora, of course, automates the failover. So for whatever reason, your writer instance is not available, the AZ isn't available, Aurora will detect that degradation and automatically fail over to one of your read replicas. And the way it determines which one to fail over to is through a failover tier. So when you create your instances in Aurora clusters, you can specify the failover tier, which ranges from tier 0 to tier 15. What we have done in Aurora Serverless V2 databases is tier 0 and tier 1 instances follow in capacity the writer instance. So when the time arises and we have to fail over, tier 0 and tier 1 instances will have the same capacity as the writer instance. There are situations where you may want to use these read replicas not just as failover targets, but also to scale your read workloads. In those situations, any read replica that is in tier 2 or above will get to scale on its own workload basis. So it's not going to match what's going to happen with the write workload. And that way, you can have separate read replicas set aside for handling, let's say, read-only workloads, which are not in the critical path for your primary transaction application. Multi-AZ Aurora clusters are covered by an Aurora uptime SLA of 99.99%. For Aurora Serverless V2 databases to qualify for that, and you would need to ensure that you are provisioning at least one read replica, which is tier 0 and tier 1, across a separate availability zone, AZ. So I have a little animation which shows this in terms of thematics, how it plays out. Now, you would see on this slide, there's a cluster endpoint and custom endpoint. In Aurora clusters, you have 3 different types of endpoints. One is the cluster endpoint, which always points to the writer instance in your Aurora cluster. Then there's a read-only endpoint, which is not represented here, but that covers all the read replicas in your Aurora cluster, and it does a round-robin DNS load balance. Finally, you can create up to 5 custom endpoints. And the purpose here is that, let's say you have a reporting workload for which you need to run a separate set of instances where the capacity requirements are not as stringent. You can group together these read replicas under a custom endpoint and have your reporting application talk to it. In this case, as we see, the primary transactional application is talking to the cluster endpoint, talks to the writer in turn, of course. The writer scales up. And with that, there's a tier 1 read replica, which is also scaling up. In the situation where the reporting app is talking through the custom endpoint, and in this case, it's going to talk to 2 read replicas, tier 14 and tier 15. So these ones are not going to scale with what's happening with the writer. They will scale independently and based on what workload the reporting application is sending to it. So again, we have a little demo which we'll walk through. Anam, take it away.
Absolutely. OK, so in this one, we're back at the RDS console. Now what you're seeing is an Aurora cluster. And within a cluster, we have a writer instance already provisioned. So you see the min and max capacity there as well. What I'm going to do is add a read replica to this instance. And for that, I'll have to click the Actions button. Just give it 1 second. And I'll just add a reader right there. Let's just quickly give it a name. Let's call it Sales Report. No need to add region. So this is where you should pay attention. Instance configuration. So we have Serverless V2 selected. And in the capacity range, we don't have to select anything. It got inherited from the cluster. In availability zone, I'm going to select a different zone. Let's use US East 1C. And for the rest of the stuff, just default settings and just click Add Reader. So now within that cluster, now we have 2 instances there. So we had the previous writer instance, and we have the new reader instance that we just added. So now I'm going to switch gears a little bit. Following the same process, I can add additional readers to it. So what we're going to look at now is how does scaling vary depending on the tier that your read replica is of. So for this particular example, what I'm showing is on y-axis, you have database capacity in ACUs on both sides. And you have 3 instances within this Aurora cluster. So on the left side, the blue color that you see is your writer instance. So the blue line was hiding underneath the green line right there. The green one is your tier 0 read replica. This is the one that's going to follow the blue line. And the orange line right there is your tier 14 read replica. Now what we're going to see is as soon as the workload starts on the writer instance, you'll see the blue line visually will start going up, showing that the instance has started scaling. So let's give it a little bit time. OK, so right there, the workload has started. The blue instance has started scaling up. And the green line, right after a little bit of lag, it's started following it. It tries to quickly catch up. And you also notice that on the blue line, I see a little bit like spikes there, which is basically just CPU gets added quickly and then memory follows. But I don't see that on the green line, because that's the read replica. There's no workload on it. It's just following the writer right there. And the orange line couldn't be bothered. It's just doing its own thing, still at minimum capacity. But when I'll add a read-only workload for the tier 14, it's going to start scaling. Now, this scaling behavior is independent of what's happening with the writer. It's doing its own thing. So in this demo, you saw how if you have a tier 1 or tier 0, similar to what we have with the green line, it'll follow the writer. But anything that's 2 or greater, it's going to do scaling independently. So Shannon, did you catch that part?
Oh, yes, absolutely. The other piece to note here is the tier 1 read replica, which is the standby. It can also process reads. It doesn't mean that it can't.
Right.
And when it does, it will also independently scale if it needs to get more capacity than what the writer has. So it can scale beyond that. Thank you.
Of course.
Next, we are going to look at Aurora Global Database. And this we are going to talk in context of course, disaster recovery and also being able to distribute your applications globally and read closer to your end users. So what is Aurora Global Database? Aurora Global Database is a feature of Amazon Aurora, wherein we are replicating, we allow you to replicate across regions with very low latency, less than 1 second. And recover, in case there's a failover, you can fail over to one of your secondary regions in under a minute. And for all of these capabilities, we are relying on the same replication technology that is used within the Aurora storage layer, but across regions. And there's dedicated infrastructure provisioned in the storage layer, so there's no overhead on your compute, again, in this case, to process the replication workload. So in this scenario, what I'm showing is that you have a primary region, in this case, again, east coast of the US. And on the west coast, you have your secondary region. If something happens, the primary goes out. The secondary region can come back up. And that recovery would be done in less than 1 minute downtime. Then in situations where you need to scale your read workloads closer to your end users, you can provision up to 5 secondary regions, and each of these secondary regions can have their own 16 instances, 16 reader nodes. So you can go up to 90 reader nodes altogether in a global Aurora database and scale your reads that way. What's interesting to note is that serverless and global database, these capabilities will work together. So you could have a secondary region which is fully serverless. In that case, if you are using it for disaster recovery, then you are not paying for the capacity just sitting around. And when the need arises, the primary region is not available, you fail over to the secondary region, it will scale up as serverless databases do and match what is needed at that point in time. And that way, you only pay for what is needed. And otherwise, if it's just idling, you pay for the minimal capacity for your cluster. Same thing happens when you are looking at scaling reads. All your secondary regions, much like the tier 2 and upwards reader nodes within a region, same way in global database for secondary regions, whatever read-only workload you're running on them, these databases will be able to scale independently of what's going on in the primary region. Major versions, these are of importance, of course. For Aurora Serverless V2, Aurora MySQL will support 8.0, and Postgres will support 13. MySQL came out in Aurora a few weeks back, so if that's what you're looking to use, it's going to be available on serverless. Compared to previous major versions, there's a lot of new improvements and features. I'm not going to go into the details of it. We have just listed some of the top features that we saw customers were interested in. And of course, these are going to be available. So read up on the documentation, and these are the major versions on Aurora Serverless V2. Then coming to the topic of monitoring and being able to debug what's going on in terms of performance in your database, RDS Performance Insights is a feature that gives you a rich dashboard wherein you can visualize your database load in terms of active sessions. So what you see here is a number of active sessions over a time scale, and the gray line, the dotted gray line, shows the estimated vCPU for Aurora Serverless databases. So this is what you would want to watch and monitor to determine if there are any bottlenecks, and you can optimize your workload to reduce the load on your database. Or the alternative is that you can use this dashboard to figure out if you need more capacity and increase the capacity on your serverless database. The other feature that's going to also work with Aurora Serverless is RDS Proxy. There's several features that are going to be functional with Aurora Serverless V2. But RDS Proxy is the one wherein, let's say you have an application which is opening lots of connections or keeping connections open and idling. This happens in situations, for example, if you're running Ruby, Python, PHP, or you are using Lambda function serverless applications wherein they can scale quickly to hundreds of thousands of transactions, but your database also needs to scale and keep up with it. So Aurora, with RDS Proxy, what you can do is you can place this fully managed, highly available database proxy on top of your Aurora serverless databases and let it take the brunt of opening and managing all the connections and preserve the precious resources in your database, your CPU, your memory, for doing what they're supposed to do, process transactions, instead of managing and opening connections. And so it does it by taking a bunch of application connections and running them on a smaller set of database connections, which it pools and shares between application sessions. The other key capability in RDS Proxy is better availability. So as we talked about failovers and high availability, Aurora automates that. In case of RDS Proxy, that failover can happen up to 66% faster because there's no DNS propagation delay. RDS Proxy continuously watches what's going on in your database and reconnects to a new instance, new writer instance when a failover happens. And during this failover, it is keeping all the connections from your application open, and any transactions and queries that are sent during that duration, it is also queuing that up and then connecting to the new writer. So it's making failovers faster and better. The third piece that it provides is better security. You can enforce IAM authentication and store your secrets, which is your database credentials, username, and password in AWS Secrets Manager. Next, I'm going to talk about all the various ways through which you can better and optimally use Aurora Serverless databases. The first piece there that we hear from customers is, how should we think about managing capacity? Now, when we talk about capacity, we are talking about the minimum capacity range and the maximum capacity that we are specifying. And Aurora Serverless databases will scale within this range that you provide. The minimum capacity determines the capacity at which your database instance either starts fresh or when it's restarted, if it is restarted, it will start with that capacity. The way you choose that capacity is to determine what's the right capacity needed for storing your working set. So whatever you need to actively work on your working set. The second factor to remember here is that the scaling rate depends on your current size of the instance. So select a minimum capacity so that your scaling rate is adequate to match what is needed for your application's workload. There are also situations where you know that you're going to suddenly see a spike. And if you know that that's going to happen, you also have control over managing your minimum capacity. You can increase the minimum capacity in anticipation of that surge so that you get faster scaling rates and you can better accommodate that scale when it arises. Maximum capacity is a budget control measure. It tells us that this is the most I'm willing to pay. This is the most capacity you should provision, and this is the most I'm willing to pay. Now, Aurora will never scale beyond the maximum ACU or maximum capacity configuration that you specify. But when you're selecting this, In addition to all your workload requirements, also remember there are features that you're enabling. So there could be, for example, performance insights. It needs some amount of resources to be able to operate. Similarly, audit logging would need some amount of resources to operate. So specify a capacity that is adequate to cover all these features in addition to your workload. Of course, it's going to be important to take a look into and maintain visibility into how your capacity is being consumed by the serverless database. So we have a bunch of metrics. I'm going to only focus on 4 metrics that are relevant for serverless databases. The first one is the current capacity, so the serverless database capacity, the current capacity of your database instance, how it is being consumed over time. The next one that you see is a percentage with respect to the max ACU you have configured. So in situations where you see that your current utilization is always closely matching, let's say 100% of your max capacity or somewhere close to that, then you have reached a state where your max capacity is not adequate for your workload, and you may want to go in and increase that. Same thing happens for CPU utilization. CPU utilization in serverless databases is measured against the max ACU configuration. So whatever CPU you expect to get with the max ACU, and what's the percent utilization compared to that. If you see your CPU utilization is close to 80, 90%, for most of the time, again, it's a situation where your max ACU is too low, and you may want to increase it. Memory is another important aspect, of course. In this case, what we are looking at is freeable memory metric, which is how much memory is available in your database instance to be able to process your workloads. If in this one, what you want to see is if there's low memory available, low freeable memory, in that case, again, you are reaching the limits of what your database instance is able to do based on the max capacity configuration you have specified, and hence you would want to increase that configuration or change your workload to make it fit better in the memory that you have allocated. Also important to note is how we manage some of these parameters. So I touched upon some of them, the buffer pool size. It is automatically adjusted based on your database's instance scaling capabilities. Same thing with table definition cache, open cache, how many tables we can read into memory. All that is automatically managed for you. There are certain parameters which are not automatically managed if you, on the fly, change the max ACU configuration. Okay, so MySQL, that's the max connections setting. So it determines how many connections you can open to an instance. And we map it to whatever the max ACU configuration was at the time the instance started. If you go in and the instance is running and you change your max ACU configuration, for it to fully take effect, what you would want to do is restart the machine when you have the appropriate time to do it so that we can increase the max connections. Similar thing with Postgres, the shared buffer is automatically scaled. Some parameters that are not include the auto vacuum, max workers, and max connections, things like that. Again, refer our documentation. These things, over time, we'll improve them. And we'll make more and more of them adjust to what is needed for the workload. But some of them, for it to take effect, you may need to restart. Will not forcibly restart your database instance. We give you that control, and you can choose when to do that. Then how do you get started with Aurora Serverless? Anum has already shown how you can create a database fresh. But oftentimes, there's a case, there's many of you are using Aurora databases. How do you start using Aurora Serverless with minimal downtime, minimal disruption? So the way that's going to work is that you can create an Aurora Serverless read replica in your existing cluster and test out the read replica based on your workloads, all that you expect to test with it. Once you are comfortable that it's functioning the way you expect it to, you can initiate a failover. Failovers in Aurora complete in 30 seconds, as I mentioned previously. If you're using something like RDS Proxy or a smart driver, in that case, the failovers will complete in 10 seconds or less, and your connections won't be disrupted. We'll hold all the transactions, queue up all your transactions, and you can seamlessly failover to this serverless read replica and start using it. And the same process can be repeated for rest of the instances in your Aurora cluster. There's, of course, the other means to come to Aurora Serverless databases. One is cloning. Cloning is supported on Aurora Serverless V1 as well. So if you have a V1 database, or if you're using a provisioned database, you can create a clone from it. Clones use, again, a copy on write protocol in the storage layer. It is quick. Within a few minutes, you will have a new database which has the latest data. You can test it, try it out, and if everything functions as you expect, you can move it. The other two options are going to be, of course, snapshot restore. So you can take your snapshots, restore them, and set up logical replication between your source, let's say, provision database, and the destination serverless database for a minimal downtime conversion as well. So with that, of course, as we have been doing, we'll show you how it plays out in practice. So demo.
Absolutely. So for this one, so this demo is for all the Aurora users sitting in the room. What we're going to do is start off with an existing Aurora cluster. So we have a cluster called Flash Sale, and it contains a writer instance, which is a provisioned writer instance, which is in our 6G machine. And now what I'm going to do is add a reader to it. So here, what we want to observe is that within the same Aurora cluster, we're going to have a writer and a reader with a mixed configuration of provision as well as serverless. So it's pretty simple to do. Once I've selected my cluster, all I'm going to do is go to Actions, and let's click Actions to add a reader. Same process that we did before. In adding a reader, just quickly call it Serverless Flash Sale. And in instance configuration now, I'm going to select Serverless V2. Now, this is the first serverless instance in this cluster, so I have to give it minimum and maximum capacity in ACUs. And then for rest of the options, again, default, let's scroll down. And just click Add Reader. So here, now you have a cluster, which is of mixed configuration. You have a provisioned instance, and you have a serverless instance. Once I refresh it, they're both available right now. Now, what we want to do is do failover. So our serverless instance becomes the writer instance, and the provision becomes the reader. So in Actions, it's a pretty simple operation. You click failover. So you get this message displayed which just asks, are you sure you want to do it? Yes, let's do it. Now, just pay attention to the screen. The highlighted blue one is the provision one, and it's writer. So this process is pretty quick. It takes seconds, usually less than, in most cases, less than 30 seconds or so. I'm going to refresh the screen. And now what I'm expecting is the provision instance, that becomes the reader instance, and it moves one level down. So now the serverless instance is the writer instance, and the highlighted one, the provision instance, is your reader instance. So this is how simple it is to get started if you are an existing Aurora user. So Jan, were you able to catch the flip there?
Oh, yes, and it's pretty handy, isn't it?
Absolutely.
The other piece is you can always continue to operate in this mixed mode. There are situations where we spoke to customers. They said that our primary writer workload is steady, doesn't vary much. But you know what? I have these tiny workloads that I run. I gave an example, accounting, reporting, which only come up maybe once in a week, once in a month. And so you can use serverless for those workloads which see these variability and ups and downs. So that's all in our presentation today. Thank you all for joining us. And please do fill out the survey. The surveys help us make better content year over year. So we'll appreciate that feedback. And I hope you all have a great reinvent.
Thank you so much, everyone.